This is section 4.8 on Newton's method of approximation. So the assignment is 6, 7, 8, and 11 through 16 all. What we're going to do is approximate zeros of a solution, roots of a solution, by a technique, a numerical technique, where it's either too difficult or almost impossible to solve by ordinary means. Okay, so Newton's method, very little bit as to what the theory is. Here's a polynomial. We're trying to set it equal to 0. How do you solve for x? Not easy, not very fun at all. Okay. So here's the theory. Okay. Assuming you have a differentiable function. First, let's guess. Okay. If you guess, you're probably wrong. All right. So here's the root. Here's our guess. Okay. It's wrong. But here's the idea now. Suppose I draw a tangent to the curve. Okay. So my first guess is called x1. It's probably wrong. Okay. Then I take this point, draw the tangent to the curve. It touches the x-axis here. I'll call that x2. That becomes my next guess. Okay. And just repeat that process on page 346. So I guess it's wrong. Come straight down, touch the x-axis. That's my second guess. It's maybe wrong. Then I come down here, x3, and notice if I keep repeating this process, okay, it seems like I get closer and closer to the true value. Okay, so this is called Newton's method of approximation. You can do the math as to what you get from all this, like you would take the tangent to the curve, you get the slope, find out where it touches here. I'll save you all that trouble, and this is what you want, and this is what you want to put on your formula sheet. Okay, box 2, page 346. The algorithm is x of n plus 1 equals xn minus f of xn divided by f prime of xn. Okay, so it essentially means you start off with a first guess. Okay. From the first guess, you plug into the function, you plug into the derivative of the function, grind all this out, and that becomes your next guess. Okay, we say that eventually that the sequence converges to R. It gets closer and closer to the particular root. Okay, it's not foolproof, it doesn't always work, okay, but for the problems that we will be doing, it pretty much works. Okay, so we're going to follow this algorithm. X of n plus 1 is xn minus fxn divided by f prime of xn. Okay, now how do you know when to stop? Well, they'll either tell you when to stop, like after 3 iterations, or here's the logic. Okay, we know we can stop if these two are equal. That means x of n plus 1 equals x of n plus 1. Okay, if x of n plus 1 equals x of n, that forces this fraction to be 0. Right? And when is a fraction equal to 0? When the numerator is 0, and that's what we want. We got f of xn equals 0, which means if we keep doing the iteration over and over, you won't get anything different. It will just stay the same because you've already found the 0 of the function. Okay, so what's going to happen is we get our function. And by the way, if they don't set it equal to 0, it has to be blah, blah, blah equal to 0. If it isn't, then just set it equal to 0. Just put everything on one side equal to 0. Okay, so let me show you the problems we have to do. There weren't that many of them. So on page 348, there's 6, and 7 and 8. And then 11 through 16, 11, 12, 13, 14, 15, 16. And that's pretty much about it. Okay, some of these can get really long. So we'll see how it goes. Okay, this is very calculator dependent, so get your calculator handy. Okay, and furthermore, I'm going to say this. If you happen to have the answer button, you're at a big advantage. Okay, if you don't have the answer button on your calculator, you can still do it. You're a little bit disadvantaged. It would take you longer to do some of the problems. I'll show you both ways. Okay, so first I'll show you the way where everybody can do it, assuming you do not have an answer button. Okay. All right. So here's problem 7. 2 over x minus x squared plus 1 equals 0. And your first guess was given to be 2. Okay, so first I need the function and its derivative. So f of x is 2x and negative 1 minus x squared plus 1. F prime is negative 2x and negative 2 minus 2x. clean it up is -2 over x squared minus 2x. All right, so x of n plus 1 is xn minus f of xn divided by f prime of xn. Okay, so xn was 2 minus, okay, then I plug into the function. So 2 goes here and here. 2 over 2 minus 2 squared plus 1 divided by, and then 2 goes into the derivative also. So 2 goes here, -2 over 2 squared minus 2 times 2. Okay, grind it out. Let's see, this is 1 minus 4 plus 1, that's -2. This is -4.5, because this is -0.5 minus 4, it's -4.5. Okay, so our x2 is -2 minus 2 over 4.5. That's -2.4 repeating. Okay. Or you could say that's -14/9. Okay, I'll show you in a second, it's -14 over 9. And then you do the same thing. So you put -14 over 9 here, and here, and here again. I have it with decimals. I'll do it to you again with a fraction. I mean, it's up to you whether you think this is better or not. Okay, so I mean, you'd have to have a repeating decimal, -2.4 repeating, minus function over derivative. So on top is the original function. So what was it? -2.4 repeating, -2.44444. That goes in the numerator. That's here, it's a little bit clumsy. And the denominator is the derivative. So -2 over -2.44444 minus 2 times the same thing, 2.44444. Okay, so that's what it would look like. Let me show you what it would look like if you did -14 over 9. So -14 over 9 would go everywhere. So x2 is -14 over 9. So x3 is x2 minus f of x2 divided by f prime of x2. So -14 over 9 minus, okay, so the original function was this. I'll put -14 over 9 here and here. It's clumsy. 2 over -14.9 minus -14 over 9 squared plus 1 divided by the derivative. It's quite messy. -2 over x squared minus 2x. So -2 over -14 over 9 squared minus 2 times -14 over 9. Okay. So punch all that mess out. I got 1.5215. Okay, it's very easy to make a mistake with something like that, but that's the way that works. Okay. All right. Okay, 4.8, number 8. X to the 7th plus 4 equals 0, where your first guess is -1. Okay, a side note, we're actually trying to find the 7th root of -4 when doing this. If I do a little bit of work, solve for x, x to the 7th equals -4, take the 7th root, so x is the 7th root of -4. So we're estimating the 7th root of -4. Okay, by the way, they might start off with this. There's a problem that starts off with this, and you have to turn it back into this form. Okay, so the function is this, the derivative is this. First guess, they said -1. Okay, so plug in -1 to the 7th power plus 4. The denominator is 7 times -1 to the 6th power. So x2 is x1 by formula, -1, minus function over derivative. So I plug in -1 here, -1 here. So it's -1 minus, that is 3 over 7, so it's -10/7. Okay, x3, do the same thing, plug in -10 over 7. So -10 over 7 minus function, so put -10/7 there, to the 7th power plus 4, divided by 7 times x to the 6th, so -10/7 to the 6th power. Okay, so grind that all out. It's a little bit clumsy. Comes out to be -1.5658. Okay, so that's what you do even if you do not have the answer button. Now I'll show you what happens if you do have the answer button. It becomes much, much easier. Okay. Number 12 asks for the 8th root of 500. Okay. So we're kind of going backwards from here. We're retracing our steps. So what you want to do is write as a polynomial. So 8th root of 500, raise both sides to the 8th power, and then subtract 500. So my function f of x is x to the 8th minus 500. Take the derivative, 8x to the 7th. Okay, now for this one, they don't give you a first guess. For problem 6, x1 is -1. Problem 7 and problem 8, they give you a first guess. 11 and 12, they don't give you a first guess. So you have to make up a first guess. Well, I tried 2. 2 to the 8th is 256. Okay. 3 to the 8th is really big. Okay. So our first guess is 2. Okay. Now, if I just follow the protocol of putting 2 into the formula, that would work. Right, 2 goes here, 2 goes here, 2 goes here. It works. It's more clumsy. But now I'm going to address what happens for those of you that have the answer key. So let me demonstrate that. So first you type in your first guess, 2. So just simply type 2. It's stored in memory. Okay. Whenever you do any mathematical calculation on calculators that have this answer key, it stores the last result in that memory location called answer. Okay, so now, yes, I could put 2 here, 2 to the 8th minus 500, 8 times 2 to the 7th, right? Put a 2 here, put a 2 here. Instead, I'm going to type answer. It's a little bit clumsier, but believe me, it saves you a lot of work at the end. So I'm going to type answer minus parentheses answer. On my button, it's second function, and then this thing. Answer to the 8th power minus 500 divided by parentheses 8, answer to the 7. And it comes back with 2.238, whatever. Okay. To the calculator, it's the same thing as if I typed in 2. You might say, well, it's a lot easier to plug in 2. That's true for any one entry, but after this, you don't want to type in the entry anymore, right? I'm guessing none of you, including me, wants to now type in, and get this into focus, 2.238. You don't want to keep typing that in. Okay, but here's the key thing. So instead of typing in 2, I type answer, answer minus answer to the 8th. It's the same thing to the calculator as if I put 2 here, 2 here, 2 here. That's the result. Okay. Now, this is the last operation. So it's sort of like stay at the last command. The calculator thinks this is the last command. It will keep doing that every time unless I change it. Okay. So all I have to do is press the enter key. So watch what happens when I press enter. That's my next guess. It automatically took the 2.23 blah, 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 and stored it there and there and there. In fact, I can do it over and over. If I can get this thing to focus. So there's a next guess, and a next guess, and a next guess. And it looks like we're converging to a number. Okay. So I will just write down, and you will just write down some of the digits for each iteration, each time through it. So first time I got 2.238, then 2.1805, then 2.174. Okay, and then after a while it matched. So now I'll just give however many digits they ask for. They ask for 8 digits. So 2.174559228 to 2 digits. And that's what I have as my answer. Okay, so it's a lot easier. You have to type that mess in only once. Okay, so one more time, the algorithm, type your first guess, and then answer minus function, plugging in answer, divided by derivative, plugging in answer in parentheses. It's clumsy, but after that, you just press the enter key. And that saves you the trouble from having to type this expression all over again. Okay, so that's that. Okay, try number 16. 3 sine x equals x, 6 digits. It says the positive root of 3 sine x equals x. Okay, well, we have no idea what it is. Okay. I know sine can only be between -1 and 1, so this can't be anything bigger than 3. So my first guess was going to be 2. Okay. By the way, your first guess shouldn't matter. It should work in any event. Okay, so first get everything on one side. 3 sine x minus x equals 0. It always has to be blah, blah, blah equals 0. And if it isn't, force it that way. So my function is 3 sine x minus x. The derivative is 3 cosine x minus 1. Okay, and I have to make sure that I'm in radian mode. So if you're not in radian mode, change to radian mode. Okay, I see that I'm in radian mode right now. Radian degrees. Okay, so I quit back out. All right, so I just make my first guess 2. So where'd you get that from? I just made it up. Okay, I know it can't be anything bigger than 3 because sine is stuck between -1 and 1. They said it was positive, so I decided to pick 2. Okay, so I'm going to type 2 as my first guess. So your first guess, you literally just type it in. So 2. Now 2 is stored in answer. Okay. But instead of going 2 minus 3 sine 2 minus 2 divided by 3 cosine 2 minus 1, I take the time to put answer. Okay, so I'm going to go second function answer minus parentheses 3 sine answer minus answer close parentheses divided by parentheses 3 cosine second answer minus 1. Okay, so it took a while to type that all in. But to the calculator, at this stage, when I type answer, it's the same as if I typed in 2. Okay, so 2 minus 3 sine 2 minus 2 divided by 3 cosine 2 minus 1. You should not type in 2, though, even though it's easier here. You should take the time to hit second function answer. Okay, because the last command was this. The calculator stays at the last command. So it'll repeat the same operation, plugging in 2.32 whatever. Okay, so watch what happens when I press enter. Focus. 2.27. 2.278. 2.27886 or whatever. And I get a repetition. Okay. So I'm going to go with 2.27886. Rounded off. Okay, those of you who do not have this button, you're a little bit disadvantaged. You can still do it. It's just a little bit longer, and whatever I give you on the test, it should be sufficient for you to work out. Okay. That's how you do that one. Okay, one more of that type. 14. Here's the function between 3 and 4. You may ignore what it says about explain how we know that a given equation must have a root in a given interval. That was way back on the intermediate value theorem. Okay, just in a nutshell, if you plug in 3 and you plug in 4, one of them is going to be positive, one of them is going to be negative. By the intermediate value theorem, that means somewhere there's a 0. Okay, so use Newton's method to approximate the root correct to 6 decimal places. So you know it's between 3 and 4. So if it's between 3 and 4, what should I pick for my first guess? I decided on 3.5. They said it's between 3 and 4, so 3.5. Okay, so here's the function. Here's the derivative, negative 10x to the 4th plus 36x cubed minus 21x squared minus 11. My first guess is 3.5. Okay, a way to do it is plug directly into the formula, which you can put on your cheat sheet. right up there, box 2. Okay, choosing 3.5. So I could put 3.5 minus 2 times 3.5 to the 5th plus 9 times 3.5 to the 4th minus 7 times 3.5 cubed minus 11 times 3.5 divided by negative 10 times 3.5 to the 4th plus 36 3.5 cubed minus 21 3.5 squared minus 11. Instead, use the answer button. Okay, so that means you're going to go 3.5 answer. That's your first guess. So answer has 3.5 stored. Now type this all in. It's messy, but you only have to type it in once and for all. Okay, so let me see if I can go ahead and try that. Answer minus parentheses, negative 2. By the way, on this calculator, to get a negative, you use this. Not this. This is subtraction. Okay, this is negative. So negative 2, answer to the 5th power plus 9, answer to the 4th power minus 7, answer cubed minus 11 times the answer. Okay, so that's all the numerator. This one's kind of long. Divided by parentheses, negative 10, answer to the 4th plus 36, answer cubed minus 21, answer squared minus 11. Okay, so all of this mess I typed in here. Okay, so you can check on your own. Okay, 3.329, blah, 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 blah. That was a lot to type in. If I did not have this answer button, I'd have to type it all in again. But since I have that answer button, all you have to do is just press enter. It will stay at the last command. 3.278. 3.2745. 3.274473. And there it is. That's enough of a match to 6 decimal places. So 3.274473. Okay, and I can stop. In fact, after that, as long as I keep pressing enter, they just repeat back. So I know that this is the solution. Okay. All right, so that's section 4.8 on Newton's method of approximation.